All right, so that was throttle unit. All right, throttle unit. Then we have the regulator unit. The regulator unit. All right, and I will say that automatically regulates fuel pressure. Automatically regulates fuel pressure to metering elements in the control unit. To metering elements in the fuel control unit. In the fuel control unit.
What is it referred as elements?
Parts, pieces, things. And let me see here. I'll pull up a picture for you guys. And the problem with even discussing the regulator unit is I can bring this over. And we have our simplified, and we have the fuel control unit. Oh, I'm sorry, never mind. But here's our regulator unit right here. So never mind where I was going with that. Automatically controls fuel pressure to metering elements in the fuel control unit. All right, where am I at here? Regulator unit. It contains. It contains one, chambers A, B, C, D, and E. Not always, but sometimes. It has two diaphragms. Two diaphragms. It has the poppet valve. Not the puppet valve. That's something completely different. The poppet valve. All right, so that is my regulator unit, which we spent most of the time talking about. And then we have our fuel control unit. And I'm going to do from this one. So in this drawing, I like it because it has, our regulator unit, which is what we talked about down here. We could even add smaller things like, the idle spring, stuff like that. Fuel control unit is represented right here with the main metering jet. So in the simplified diagram, it's up here. If I were going to go to my more complicated diagram, which is way down here, then I would say that my fuel control unit should be something like this area. So I'd make this my fuel control unit because it contains the idle mixture, the metering jet, derichment, economizer, most importantly, the main metering jet. And so, yeah, sure, why not the mixture control? So fuel control unit. There we go, fuel control unit. What receives? It receives the fuel under varying pressure from the regulator. So receives fuel. Oops. Fuel under varying pressures. Varying pressures from the regulator. From the regulator unit and meters it to the discharge nozzle. And meters it to the discharge nozzle. It has one or more metering jets. It has metering valves. I should just say it's a very this is a very complicated piece. Metering valves. May also contain the idle needle valve. And that brings us to the discharge nozzle. And its purpose is to inject fuel into the airstream. We haven't talked about this yet, and our drawing does not show this, the one I've been working with, but depending on which type of carburetor, some carburetors, it will mix air. I'll be careful. It's actually from chamber B, but I'll say mix air to emulsify.
Who's doing laundry?
You can hear the laundry. I should give you a tour of my house. On my left is the laundry room. In front of me is the bathroom.
Oh boy.
I'm in between the laundry room and the bathroom.
Are you serious?
Kevin?
Yeah.
When you say chamber B?
I want to be careful about saying chamber B because it's just, that's really in the PS5, which you guys will see. So I'm just going to leave that off. So I just put mix air to emulsify the fuel. That way I'm never wrong. Because if I did it and you're thinking the PR58, the one we've been looking at, you're like, wait, I don't see where B gets to it. So I'll just leave it off. So it is a form of a pressure relief valve, And yes, back to the laundry situation. It's a big family. We have 2 washers and 2 dryers, and they run pretty much 24 hours a day.
Oh boy.
I
I would not want your power bill.
I don't want my power bill either, so I guess we have that in common.
What about the water bill?
Water bill's not too bad. Water, sewer, garbage for me is about $160 a month.
That's cheap.
Yeah. And I do have solar, so I got that going for me.
How many kids do you have?
6. 6 kids, 5 dogs, 1 cat.
Did you build that house?
No, not at all.
How did you have enough room for 2 washers and 2 dryers?
I pushed them in there with a shoehorn and well, are we really off the subject here? The washer, I bought stackable dryers because my wife wants front load dryers, but she does not like front load washing machines. So there's enough room for 3. So the washers are side by side and then the dryers stack.
Got to get crafty.
Yes, and one dryer runs off 220 and the other one runs off of natural gas. So that way we had enough power to run each one of them. Okay, so pressure discharge nozzle, it's a form of a pressure relief valve. It opens at a preset pressure and keeps this keeps the downstream pressure at a preset value. Which we're saying is 5. Usually has, we have not talked about this, but we're going to get into some more of these nuances, especially with the next carburetor, because it's got a more detailed drawing. It's a little bit more simplistic of a carburetor, which allows it to have a more detailed drawing. Usually has a fuel shutoff ring, shutoff spring. And that's an auxiliary spring that they put in there. instead of just, as the drawing shows, it's just like one big spring when the diaphragm just pops open. You want an absolute definitive shutoff with this thing. So the last thing you want is for this thing to be dribbling a whole bunch of fuel, because if it's dribbling fuel out, then you're going to get fuel going into the cylinders, and you're going to get this kind of like this run on where it just kind of chugs along. And I'm sure you've heard that before. And it doesn't shut down. And so then everybody looks at you, hey, what's wrong with your engine? And so, no, it's just, I don't have, it doesn't shut off. So you want a nice, positive, quick shut off when you want it off. So this keeps fuel from dribbling. That's an industry term. Fuel, this keeps, oops, let's try writing all the words. Fuel from dribbling. Dribbling into the engine. At ICO. And everybody should know what ICO stands for, which is?
Idle cutoff.
Idle cutoff is correct. And the reason why I'm using that is because that is an industry actual term, and you will just see that. And it's sometimes even stamped on things, ICO, and you're like, oh, what do you see? So ICO. Open this vent. May be connected to chamber B. Chamber B to assist spring. So we're going to look for that as we go. So some of those notes were a little bit about two different carburetors, but that's okay. We can just kind of keep that in mind as we look at it. And I'm going to let you guys get caught up there so we can shift gears. So Nick, you're gonna have to tell me whose airplane is that you have a picture of. Is that Tyler's? All right, Eric's done. All right, so Janet, you're good?
Yes.
Okay.
Keep going.
And Dominic, did you ever show up? Was it Dominic who didn't show up?
Yeah, I texted him, but he didn't reply.
Okay. Yep, Dominic's gone. Okay.
It sounds like a Monday today.
It does it? Yeah, that's true. Okay. What else we got here? All right, let's move. We'll shift gears now, and so that's, really in a nutshell, that is the big PS5. And so now we're going to look at, I'm sorry, I said PS5. That is the PR58. That's the big PR58. And now we move on to, and I didn't want to do that at all. I want to do this one. There we go. The little PS5. So this PS5 is something that's actually a pretty common pressure carburetor. This is what runs a lot of small aircraft. It runs our Bonanza, our V-tail Bonanza, and it comes in a lot of different flavors. And you can see up at the top here. What do you suppose those are?
Looks like a discharge nozzle.
Impact
Well,
air tubes.
That's why I asked that. It's either the impact tubes or it's a discharge nozzle. And it's just going to depend on which way the air is flowing. Oops. What did I go? This particular carburetor here. Hang on, let's see if I can minimize that, find myself so I can see what you're seeing. There we go. So this particular one here, which one is this? Let me just see. Yeah, it's a PS5. I can't read the designator, but it's a PS5. This has, I showed you, you don't see the impact tubes because it comes back in here kind of behind this is the inlet here, which is bigger. And then, so that means the discharge nozzle here, which is a little bit different. It's kind of hard to see on this one, but that's that particular carburetor. So, all right. That was supposed to change. There we go. Okay, so now we can talk about the how this one works. And this is going to be the drawing that we're going to work off from this one, which, like I said, it's a far more simplistic carburetor. So it is got a more detailed drawing. I'm sorry about that.
What was the name of this carburetor again?
What's that?
What was the name of the carburetor again for this one?
Right down here, PS. The Bendix PS carburetor. So right there, PS5 to be exact on this one. The one I was holding up is a PS5 Bravo Delta made by Bendix. So it actually says Stromberg on it, but we call it the Bendix because Stromberg was purchased by Bendix. Bendix makes all kinds of stuff. All right, so what we'll do is we will just go through kind of the overview, work your way through this, and then I'm going to come back and then we will write some notes about it and go back and forth. But I think the easiest way to just jump in here and kind of take a look at it. So if we look at this, let's start with the things that we know, or since I'm talking, I guess the things I know. So first thing we'll look at, we started with those chambers, A, B, C, and D. So we can see chambers A, B, C, D, and there is no E on this, but yet things kind of have to work the same. We know that. And so what we're going to do is just follow what we know and see, you know, does it work with this? Does it not? So we can start off with the fuel inlet is right here. And I like this one because it's nice and color coded. We come through here. We have a fuel strainer. So fuel strainer, fuel screen. This, of course, fuel pressure connection. That means it's going to go to usually to like a pressure gauge or something. Poppet valve and vapor vent. Now, we saw before on the big one, the PR58, that the vapor vent had a float. This one doesn't have a float. It just has a little tiny orifice right there. And hopefully you guys can see the orifice and everything, okay? And so we will just assume here, well, it's true, that fuel and air, any air bubbles are going to collect in this chamber that's just running up here. And as the air bubbles start to accumulate, when they get down to here, there is a fuel that is being jetted this way. And whenever you jet fuel like that, you create a low pressure, and it actually works like a vacuum. In fact, my first experience of this, in the Navy, we had these things called ejector pumps, which was nothing more than a giant venturi. And you would actually, see if I haven't thought about this one in a while. But we would have these pumps that we could, if we had a compartment that would flood, and they were shaped like that, which looks like a what?
Venturi.
A venturi. And then you would hook a fire hose up to it. This would be my fire hose inlet. And the fire hose, remind you, you're trying to drain a flooding compartment. So the first thing you do is hook up a fire hose. And this fire hose would basically would blow water up this way. It had a bunch of nozzles around it, which would create a low pressure area, which would then suck any debris right up through this big venturi. And you'd hook another big 4-inch hose up to this, and all the debris and everything would go out that way. And so you didn't have to run a pump with an impeller in it where a mattress or somebody's hat or whatever gets stuck in it and make it not work. So it's, you're going to see this again in the Continental fuel injection system, where they use an ejector pump. And so that's what that is. So by creating this little nozzle right there, you actually create a low pressure, and it's going to spray out. Or in this case, it's not so much of an ejector pump. It's just fuel is actually leaving and going this way. And so any air bubbles that accumulate up here are going to shoot out. Where do you suppose that's going to be plumbed to?
The tank.
The fuel tank.
Fuel tank is correct. Please don't say overboard. That would be a real waste of fuel just to have it constantly. If somebody pulls up, hey, your airplane's leaking fuel. I don't worry about that, man. It's just my vapor vent. Vapor vent cost me about six gallons per minute, but don't worry about that. Okay. So those are vapor vent.
Would
So
that section be basically the chamber E on the other diagram?
That would be all of this purple. We could call it chamber E, and I don't think we'd be wrong with that at all. Okay, so looking what's different. Well, one of the things that's really kind of hard to get used to right here when you see this area, I'm just going to enlarge it real quick and I'll go back out of it. Or will I? I'll just think this way, is that it appears that this is the poppet. Not that it appears, it says that. But what I can see is there's a seat right here, and the needle seat is right here. And so when you look at that and you think, okay, well, air metering force is going to push to the right. B is suction, it's going to pull. Well, then that's making this mode to the right. And the more it goes to the right, the more that would be closed. Now, how am I going to make that work? Well, that's not what's going on here. Whatever this is right here, it appears to be some sort of stop or something. I don't fully know, but the needle and seat are way up in here. It's this little tiny thing. So the needle and seat is here. So it's going to work the same way. Don't let this right here trick you into thinking that that fits into here and somehow that is the needle and seat. That's just not true. Okay.
That might be just to stop it, right? And keep the pressure.
Might, but I don't even
equilibrium.
See. Yeah, I don't see anything for that. But okay, so we got fuel coming in, but let's stop there and just go over to the air side. So, all right, so we have chamber A. What is chamber A? And I'm just trying to figure this out. Follow through here. It's the blue, and so impact air. All right, so now we can work with that. So here's impact air, and impact air comes in, and we know that impact air, as we have more throttle, is going to increase the pressure in A, which will move the poppet to the right. Okay, that works for me. And chamber B, we know chamber B is Venturi suction. It just comes through here, and it's kind of hard to figure out, but it's all through here, and it says Venturi suction. So we know that's Venturi suction. So suction, the more we open the throttle, the more suction we get, the more it's going to move the poppet to the right. And that's where all of this would not make sense if you didn't know that. So the poppet goes to the right, and it's going to open up the seat right here. And the more pressure I get in A, the more pressure I get in B, the more the poppet is going to open, allowing fuel to come into chamber D. That's where I get my equilibrium. Now, before we had C into play, there is no C into play here. It's up here doing its own thing. So it's A and B is air metering force. Fuel metering force is strictly going to be D. So the first question is, well, wait a minute. In order for that to work and be in equilibrium, that means that A plus B has to equal D, right? And it didn't work that way on the other carburetor. There wasn't enough A plus B. In fact, I even told you that. In the other carburetor, I said it was A plus B plus C has to equal D in order for it to be in equilibrium and not be sliding back and forth to infinity. Well, in this one, it's A plus B has to equal D. So, and C was like 5 PSI. So we just lost 5 PSI and somehow we're making it work. So, you know, please explain this one now. Well, this is the way it's working here is you have to realize that not all of the diaphragms are actually the same size. And you can make diaphragms bigger or smaller. And they've even indicated that where this one is taller than this one. So A is a very large diaphragm, if you will. And so it's just a pressure multiplier. Remember, pounds per square inch is just PSI is pounds per square inch. So if I have, and this is one of the questions you guys end up getting on one of your oral practical tests, actually. It's got something like a piston of X number diameter is pushing on a piston that is this big. And it like asks something like, it gives you all these parameters. And, you know, if there's, if this has 10 inches square, 10 square inches, and this only has 1 square inch, inches square. How much pressure would it take here to equal the pressure here? And I don't want to go through the whole math, but just know that a little bit of pressure in this chamber A, a lot of pressure in A will equal I guess, It takes a lot more pressure in B to move. So because it's every pounds per square inch. So actually we can figure it out since it's 10 to 1. So if I had 10 PSI on B, how much would it take in A to make this not go right or left? And answer should be 100, right?
Mm-hmm.
Well, yeah, 10 square inches. So that'd be 100. So if I had 10 PSI in B and 100 in A, which way would this move? And the answer would be
Nowhere.
nowhere. It doesn't move at all because of the size difference of the pistons. So
the other way around.
Yeah, it's the other way around. Thank you for helping me because I was stumbling all over that. So yeah, how are you guys ever going to get around this if I'm giving you the wrong answer? And it certainly would. Laser pointer. So, oops. Thank you. First of all, thank you for correcting me, and thank you for those who actually knew where I was going. So 100 PSI here. So do the math. 100 times 1 equals 100 pounds of force. 10 PSI on this one times 10 square inches would equal 100 pounds of force. So 100 equals 100. So it would actually go nowhere. All right. So using that theory, then I could change the size of these diaphragms and pull out the same thing. I hope you followed that. I hope you stayed with me down the rabbit trail.
Honestly, if you could go over that one more time, because I was a little bit confused.
Were you in the bathroom or talking to your friend on the phone?
No, I wasn't. I'm genuinely listening. I'm trying because you did 10 psi. Like I'm kind of confused, like how you multiplied it because it's per square inches. So if it's 10 square inches and it's 10 psi, you get 100. Or is it like because the other one is 1 square inch?
Okay, so let me go back. My whole point behind this whole PSI thing over here to the right was that back on the PR58 carburetor, we needed A and B and C to equal D. And I told you it's because A and B don't equal a whole lot because there's just a little bit of air pressure. And here I've got 9 to 14 over here in D. So on the big carburetor, that's how it ended up working. It was, you know, if this is 9, D was, I don't know what I say, it came out to 8. And so these two together equaled 3. So that would be 5, that equals that. Well, we're right back to the same thing. I mean, we have a smaller carburetor with less airflow. And suddenly I'm going, well, wait a minute here. So if these two things still equaled 3, then D has to equal, and D is 8. Well, then wait, where's the middle? What happened to my 5? All right. And what I'm saying is the way they do this is they use the size of the diaphragms. So the square inches of this diaphragm between A and B, you can make that a lot larger than D over here. And there you have it. And another thing is, let me see. It does appear that we have a diaphragm that is actually connected between B and D, which it didn't have before. So something I hadn't thought much about before, but the fact that that diaphragm is actually there and would suction want to pull this in a little bit, well, that would actually multiply D and make it worse. So I don't like that idea. But anyway, so we lose D, all right, but we still have to, we lose C, but we still have to be in equilibrium. Now, I'm not going to ask you to elaborate a great deal upon that. I do on the other one, but this one, it's just, we don't have C, all right? So it's got to be compensated inside of that. So moving on, we go into C, which does not act on the diaphragms. And C comes over here and across, and C is running through here. Now on the other carburetor, and so this is sort of, well, there you go, main metering jet, just tells you. Now on the other carburetor, it did have like a little slide in the idle. So we got to think about idle. And we can see right here, this is the idle needle valve. And I'm going to get more into the idle needle valve in a little bit, but it's a stepped valve that allows different positions. So this idle needle right here, number one, I can see that it's connected to a diaphragm, which is connected to suction. And I can also see it's mechanically linked over to the, well, it just says manual idle extra rod. So it's manually linked to the throttle valve. So we're going to have a manual link, just like we talked about before. So in idle, we have the idle spring that is going to hold the poppet off the seat. And I'm just going to tell you, we have a manual needle right here that is going to vary the proper amount of idle fuel. So idle fuel is going to come, we have to come through here. It's going to come through here. It's going to let idle fuel through, or at some point, all the fuel, depending on what we're doing. So we can see this will move it back and forth and slide that. So we'll get into that. We're going to come up into here, and we have the accelerating pump, which works very different than the other one, but it's still kind of cool. So we have an accelerating pump chamber, but doesn't appear to go anywhere. So we can back up here. We come up here to the discharge needle valve, which we know about how that works. It's like a pressure relief into the discharge nozzle and up. And here's this pressure right here. That's actually, it's coming out of A on this one. Coming out of A, the pressure, which adds to emulsify the fuel. So really, you know, nothing spectacularly different about this. The only thing we can really get into is the fact that C was just moved up to here, and we have a few other nuances. So discussing some of these little nuances, we come back over to here, and we can see that we have a manual mixture control needle valve idle cutoff arm. And this right here, it's kind of cool. I don't like the way the drawing works. It's sometimes sort of hurts your head. But what happens here is we can see right here, this is the manual mixture control. So how does the manual mixture control work? Well, if it's all the way forward, we can see that the impact air comes through, and if it's blocked, it's not going to go anywhere. But as I pull the manual mixture control back, it's going to open this needle, which allows the impact air to vent into here and go into the venturi suction in this way. So it bleeds off this way. So,
Kevin,
yeah.
can you zoom in, please?
Yeah. So with this all the way closed, all of the impact air goes to the impact air, all the suction go to suction. But as the manual mixture control pulls this out of the way, it starts stealing some of this impact air from going into here. So it steals it. Not only does it steal it, but there's suction here trying to suck on this diaphragm. Well, now it's not. Now it's getting air here. So it's like a 2-for-1 shot. It robs impact air and it satisfies the suction, if you will, from pulling on the diaphragm. So you get no pull, less pull on the diaphragm, and you rob it of impact air. So that's how you lean this one out. All right. So that's just your manual mixture control, but it's kind of cool. The more you pull it out, if you pull it all the way out, see, it says idle cutoff cam. What happens when you pull this out to the point where this ramp hits this, it pushes down on this lever, which pushes up on this, which actually locks in and pulls this this out of the way. I'm trying to think. I had a good drawing one time that really explained it, and I don't know where it went right now. Anyway, it locks the idle spring and keeps it from being into play. So it like pulls it to the left here, pulls it this way, and locks this down. And so when I go back, so this should be actually open right now and not in effect. So this should be down and it should be released. I guess the way I like to explain it is if you think about this floating a little bit, this is floating. When this comes up, it's going to push it right here and yank it back this way. This is the best way I can do this drawing. And we'll say this is a pivot. So if you can follow that, this pushes on this, which pulls it this way, which pulls this, which pulls this, which yanks that right back in.
Kevin, what is the black line?
This?
By the no, the other one.
This?
The little, yeah.
It's representing.
Is that another diaphragm?
It is not. It's actually kind of a hard piece, as far as I know. But it is. I don't think it's rubber at all. It's just a.
Is that just the seat for the spring?
Yeah, that's what I think it is. Seat for the spring. So I don't force you guys to get into quite that kind of nuance. I do ask how things work, and why do you have this cutoff cam? Because the cutoff cam is actually, I don't know if you can see that up on the camera. Probably not, because I have it way over there, but you can actually see it quite well. Let me see if I can do this. This thing's heavier than I thought. So there it is. Oh. Okay, so let's see. We'll leave it zoomed in because that's a good idea. So that was the idle cutoff, and that's the mixture and idle cutoff. So that's the two things over here that are sort of new. Come back across here. I'm going to follow it through here. Come over to here, the idle needle, and let me see here. I want to pull open. Wow, the very next slide. Okay, this is a better close-up of what we're talking about. And this is really what I want to point out right here is this stepped needle. So think about the fact that we're at idle and we're running on the idle spring. And so things are kind of locked into place, and this is going to deliver a set amount of fuel. And so you can see by this drawing that's quite well, initial idle about 25% power. So it's right in here. So right in here is slow idle. So we'll say this is blocked off. It's going to block off the passage. Then this is the slow idle. And then as I increase the idle, I'm going to need a little more fuel. So manually, it just opens this up and says, well, you get that much fuel. And then as I go into 70 or 65% power, say, well, I'm not going to give you all the power, but this is appropriate. And then after that, you would go wide open, and then it all runs completely off of the diaphragms, if you will. So that's what that step needle looks like, but it's really tiny down in there. And so you can see this is the same thing. Here's the, right here is the lever that comes over here and allows it to slide on here. So I'm going to go back one. So it's just that step needle. So I want you to just be aware of the step needle in there. Carburetor never even renew its real needle. All right, back in here. Okay, so what do I want to say about the manual mixture rod here, or the manual idle control rod? There's a certain amount, you can see that it's mechanically linked, and it comes down into here, and the mechanical linkage changes spring pressure. And in addition to spring pressure, we have vacuum and fuel pressure here. So there's a certain amount of adjustment or control that you get manually with this. And the rest of it's going to come from fuel pressure, pushing this back, in addition to Venturi suction pulling it back. So at some point, if, I want to say, because Venturi, if the throttle is closed, you're not going to get much Venturi suction. And if you're not getting much Venturi suction, then you're not going to have the poppet open very far. And if you don't have the poppet open very far, you're not going to get much fuel going into chamber C. If you don't get much fuel going into chamber C, you're not going to get much pressure pushing on this diaphragm. So we don't have much vacuum, and we don't have much pressure. And so those two things are going to say, you know what, let's don't open this valve very much, because if we do, we're going to flood the engine. So even though this may pull back and pull some spring pressure and say, hey, you should open, it's got to wait a minute for the fuel pressure to catch up and the Venturi to catch up before it opens. And so that's a good example of something that was designed so that you don't stumble when you open the accelerator too much. So
that causes a delay too?
Yeah, an appropriate delay. Accelerating pump. This is kind of and I'm going to write notes for you guys. So accelerating pump. Let me see. So interesting way that it's drawn. So we have this and this, right? And those two things are, as we already know, chamber C pressure, metered fuel pressure. What they didn't do is color that right there. You guys see that little bar right there? That's the trick to how this thing works. And they forgot to color it in, because the person who does the coloring probably didn't think it through. So what happens is fuel under pressure is going to come, well, it's coming down here, go through the needle. It's going to come up here. It's going to fill this chamber up, and it's going to run through here, and it's going to fill this up into here. So now I have fuel pressure that is on this side, but let's take a look at this. This is some sort of little poppet thing that can open up. And so any sort of pressure here is going to push this closed. This should probably have been colored too right there. So that should have been colored, and that should have been colored. And this should it's not capped and locked. There's like exits here. So what happens is you have pressure comes in here and fills this up. Well, this right here, this color comes right through here into here. And this is my manifold pressure. So here I am at idle, right? And when I go to full throttle, what's going to happen is there's going to be a sudden pressure increase of manifold pressure. Because right now at idle, this up here is actually a vacuum. It really matches this color here for the most part. It's Venturi suction right up, it's here, but up here it's a lot of vacuum. And so that vacuum comes through here and goes to here. And all of this vacuum is going to pull this all the way back as far as it can, right? Because remember that at idle, the engine is sucking really hard against this throttle valve. It is a massive vacuum, super low pressure. And so super low pressure comes through here. This becomes a super low pressure. It pulls this diaphragm back as far as it can against the spring pressure and fills this up full of fuel. Fuel came through that little chamber right there that's not colored. So here we are. It's cocked and loaded is what I would say. It is ready to do something. And so when I open up this valve right here, I'm going to lose the suction here and go to a manifold pressure, which is going to be much closer to ambient. I lose the suction. Now the spring is going to win and it's going to force this diaphragm over. This fuel has to go somewhere. It's going to pop this off of its seat and blast it right out into here for an extra increase of fuel pressure that is going to run up here to the discharge nozzle and shoot it out that way.
Hey, Kevin.
Yeah.
Where did you say that the accelerating pump suction channel goes to?
Right here.
So it just goes right out to the side, basically, or?
In here, where can you see the hand going floating around?
Yeah.
Okay, so right in this area.
Okay.
So manifold pressure, but it's manifold suction during idle. So idle cocks it like a gun, not like something else. So
I gotcha.
Yeah, when the throttle is closed, there should be a passage that goes to the Venturi, right?
no, not
the
Venturi,
one
right here.
on top of the
Yep,
throttle.
because you want the
plate.
suction at idle, not Venturi. Because if I did Venturi, then I get suction at wide open throttle. I don't want suction then. I want to lose the suction when I go to wide open throttle. So put it up here. This is the inverse. This is suction at idle and not at wide open throttle. This right here is no suction at idle and suction at full throttle. So Venturis are backwards. So, but yeah, it draws it in here, sucks it in here, blasts it out here up into this chamber. And then we can tell by this chamber here that it comes down to Venturi suction, that Venturi suction will pull back on this. So the more Venturi suction we get, the more it's going to want to pull this back and open up the needle for wide open operation. And then we already said we get air, discharge, air bleed comes in here, mixes, emulsifies, and comes out there. And that is really that carburetor in a nutshell. And that brings us to 519, so you can have a break.
On that accelerating pump, why does the channel go back down before it goes up to the discharge nozzle?
Here?
Yeah.
Why does what?
It goes down, and then it's got to make basically a 180 to go up.
Oh, instead of going this way?
Yeah.
I don't know. It's the way they did it. I think it was, I don't know. Oh, why didn't they color that in or that in? I don't know. And, you know, and why doesn't this go somewhere? It looks like it just goes to nowhere. So I don't know. Just, you know, misdrawn or something. And then this is just the way it's been. So, all right, I'm gonna give you guys a break.